Alright, so in this section we're going to talk about division of polynomials. So we're going to talk about long division, synthetic division, and the remainder theorem. So this is section 2.3 in the textbook. Okay, so let's talk about long division and how to. So you probably remember how to do long division by hand for just numbers, and hopefully you remember how to do this because we're going to use this same idea for just functions and dividing them into each other. So let's say that we're dividing 36 into this big number here, and we're doing this by hand. We don't have a calculator. So the first thing that we do is we look at our number and we start going this way, right? So we divide 36 into 51, and we know that it only goes in one time. So we put 36 here, we put 1 over the last digit, that what we were using, and then we put the 36 here, and we subtract that entire 36 from the 51. And we bring that down, and that gives us 15, and we bring down the 7. So we bring down the 7. And then we do the same process. We divide 36 into 157, and we get 4, remainder this. So we'll put 4 in here. So 36 times 4 is 144. We put the 144 here, subtract 157, and we subtract 144 from that, and we get 13. We bring down the next number, bring down the 6. We do this same process. 36 goes into 136 how many times? On the side, sometimes we need to do scratch work. And so we're not going to want to use 4 because that was too big, so let's use 3. So we get 18, so we get 108. And we do the same thing. So we'll get 8, 2, we get 28. And that was going to be 3. So we put 3 over that. Then we bring down the 2. Right? And we keep going until we're left with bringing down the 4. And then we get some type of remainder. And then we get a number there. Okay, so that's the process behind long division for numbers. Let's do the same thing, but with an x term. So let's do the same thing, but let's use x. So we take x. X goes into 3x squared how many times? So we can do 3x squared divided by x on the side, and we get 3x. So I need to multiply x times 3x to get 3x squared, and that's my goal. Is I'm trying to clear these here. I'm trying to clear those first digits or those first terms. So I need to multiply by 3x. So the 3x is going to go up there. So now I bring down this, and I get 0. I bring down the 2x, so plus 2x. Now, x goes into 2x how many times? Just 2 times, right? We need 2 times x. So I get 2x, subtract away. I get 0, bring down the 5. How many times does x go into 5? Nothing, right? We cannot, there's no x's there for us to go into. So I have remainder 5. Now, we don't actually want to use a remainder anymore. So in this class, we get rid of a remainder and we add plus 5 divided by whatever we were using originally to divide, x. So that's what we're going to have. Now, this kind of is like a factoring trick, right? Because what I essentially wrote was 3x plus 2 plus 5 over x. That's essentially what this is, if you want to get back this original one there. All right, so now let's try it when we don't have just x. We have a plus 1. Let's try that. So using this same idea, it's exactly what we want to use. Now, don't get intimidated by this piece here. This 1 here is virtually just, we're not going to use it for anything. We're always going to be looking at this first term here and dividing it into the polynomial that we have. So x goes into 2x squared how many times? So we can take that 2x squared divided by x, and we're going to get 2x. So I'm going to put 2x over here over my 3x. Now what I have to do is I need to multiply this 2x onto the x, and I get 2x squared. Plus, now since I have this plus 1 here, I have to multiply that times this 2x. So I'll get 1 times 2x is that. So I'll get this is the polynomial, or the quadratic I'm subtracting away. All right, now I distribute, so this is minus this and minus this. Now you have to be very careful with the signs. Okay, so I get 0, and I get x. I get plus x. Bring down the next one. I get minus 1. Can x plus 1 go into x minus 1? Well, x can go into x one time, so I can add 1. Now I need to multiply. So now I'm subtracting x plus 1 in parentheses. So I get minus x minus 1, so I get minus 2. So I have 2x plus 1 plus negative 2 divided by x plus 1, or remainder negative 2. Okay, so we call this 2x plus 1 the quotient, because that's what we get back out, and we call this negative 2 piece the remainder. The divisor is that x plus 1 that we have on the outside, and the dividend is the 2x squared plus 3x minus 1. So that's what long division is this repetition of multiplying, subtracting, multiply, subtract, multiply, subtract. You're going to want to reference Alex to practice these kinds of problems, right? Because they do get long and tedious, and you have to really be careful with your signs. So this idea follows what we call the division algorithm. Now, in this class, we're not really going to be focusing too much on using this division algorithm idea with all of this Q's and R's and stuff like that. The division algorithm is really important in theoretical math, and specifically one field that uses it a lot is cryptography and number theory, because finding primes and stuff uses a lot of division of numbers. Because if you think about composition of numbers, right, primes are meaning that there's only factors 1 and itself, and so you try to factor everything right down to primes and having no remainders and etc. So division algorithm is used widely in number theory, so that is something that you will see it in. And if you're interested in that kind of idea, a quick Google search, or feel free to reach out, because I'll be more than happy to talk about that. So this is like the formal definition of what we're doing with long division and such, but we just need to understand how long division works. So we are asked to divide this polynomial, and so a lot of times our division is going to be asked in different cases, so in different ways. They're going to write it differently every time. So let's divide this. So we have x minus 2 here, and we're asked to divide that into 2x squared plus 3x minus 14. So let's do this. So first thing, x goes into 2x squared how many times? It's 2x. We did the same kind of thing from the last time. So I'll get 2x squared here, minus, now I need to multiply this 2x here, and I need to multiply this negative 2 here. So I get minus 4x. All right, now I'm subtracting that entire quantity from this chunk here. I'm going to remove my parentheses and distribute that negative here to get a positive. So I get 0, and I get plus 7x. Bring down this minus 14. Now, as you can kind of see, you should be able to see something's going on here, right? So now what I'm going to do is I need to figure out x goes into 7x how many times? 7 times. So plus 7. So I have 7x minus 14. 7 times negative 2. Notice that those are the same exact things. Well, those are going to cancel out, and I'm just left with 0. So I have a remainder of 0. Well, we just factored 2x squared, right? We factored this piece here into x minus 2 times 2x plus 7. And that's all we did, was we just factored, even though we did long division. And so something that we're going to be asked a lot to do in this unit is check if something is a factor of a polynomial, right? And it might seem easier for these kinds of examples because we have, x squared and stuff like that. And you could easily factor this quadratic. You know how to do that. But they're asking us to divide, and they're giving us essentially one of the factors, or what we call roots, if you remember from the previous section. Okay, so long division is great, and it works for all cases of division that you want to use. But there's an easier trick way called synthetic division that helps when we're trying to divide stuff like this. So we knew from last time, right? So we had 2x plus 7. So we had 2x squared minus plus 2x minus, so we get 0 plus, oops, this is 4, plus 7x minus 14 minus 7x plus 14, or minus 14, and get 0. Okay, so remember we had a remainder of 0. And so this way is great if you can do it quickly, but there's an easier way called synthetic. So I'm going to teach you how to do synthetic division. It's the same idea, but you're just using the coefficients and you're kind of playing like a little number game. So in order to set up synthetic division, the first thing that you do is you look at what you're dividing. And so we had x minus 2 is what we're dividing. And so we set up this little box here in the corner. Okay, and we set up this little box here. And we put this number here, the opposite sign, we put it here. So if it's minus 2 here, we'll put 2 here. Okay, if it's plus 2, we'd put negative 2. All right, but for this case, we want a minus 2. And then we put all of the coefficients here. We have 2, we have 3, so we have 2, we have 3, and we have negative 14. So this implies 2x squared plus 3x minus 14. That's this row here. Now what we do is we do a little number game. So the first thing we do is we bring down this 2. You always bring down that first number there. So bring down the 2. Multiply the 2 times the 2, and we'll get 4. Add those together. 3 plus 4 gives me 7. Multiply the 7 and the 2, and we'll get 14. Add those together, and I get 0. And this should look familiar because this is 2x plus 7, remainder 0. That's what this row here is saying. And so this synthetic division is a really quick little way to check to do division. And so whenever you're doing it, is you're always multiplying, multiply, add, multiply, add, multiply, add. That's what you're doing. You're always doing addition. Okay, so some things with synthetic division is that it does not work if you have, say, 2x. It doesn't work with coefficients. It doesn't work with x to the third. Say you're dividing this into something. It only works generally with factors like this, x minus 2, x plus 2, x plus a half, things like that, and anything just to the first power. So we'll keep it like that. Okay, so let's do another problem where we're asked to use synthetic division to divide. So let's start. Okay, so we need to divide this guy by this. So we look at our what we're dividing by, and it's x minus 4. So I know that I have to take the opposite sign, which is 4, and I stick it in the box. Okay, now I need to look at what I'm dividing it into. Now, first of all, there's a lot of things going on, but the first thing that I need to notice is that it's not written in descending order. So I need to rewrite this. So I'm going to write 2x to the third minus 10x squared, and then I have minus 5. Now, notice that I'm missing an x. I'm going to put a plus 0x in here as a placeholder, which you have to do for synthetic division and a long division. Whenever you're dividing into something that has a missing term in descending order, you must put a placeholder there as a 0. You have to. Because if you do not, it will mess up the entire calculation. So, first thing that we do is we'll grab all of those coefficients. So I have 2, negative 10, 0, and minus 5. All right, so those are all of my coefficients. Let's bring down the 2, and let's start our little game. So we bring down the 2. 2 times 4 gives me 8. 8 plus negative 10 gives me negative 2. Negative 2 times 4 gives me minus 8. Minus 8 plus 0 gives me minus 8. Minus 8 times 4 gives me negative 32. And negative 32 plus negative 5 gives me negative 37. All right, so this had degree 3. whenever you do division, it loses a degree. So now this is degree 2. So really, if I wanted to find out what this polynomial is I'd have 2x squared minus 2x minus 8, remainder, negative 37. Or plus negative 37 divided by x minus 4. We always put it over what we're dividing. And so that's how we do synthetic division. All right, so that's how synthetic division works. All right, so another thing that we want to talk about in this unit is the remainder theorem. And so consider a case where f of x is the dividend, which means that you have some type, that's the answer that you get out. And x minus c is the divisor. So we have this kind of expression, okay? Now, f of x is going to make up that factor times something else plus the remainder. Okay, so that's what we have. And so if you have this statement here, and if you evaluate it at f of c, right, the c's are going to cancel out. So c minus c times q of x plus r, that's 0, and you're yourself with r. So this is you can ignore this part if you want to. All you need to take out is that if a polynomial is divided by some type of a factor, and then the remainder is that f of c, right? So the remainder is that f of c. So this is telling us the value of f of c, okay? Okay, so this is very, very confusing, the way that it's worded. But basically, if you divide a polynomial by the factor of what you're evaluating. So let's look at this example. So you're asked to find f of 2. This is the polynomial that you're given. You look at this and you're saying, okay, I have to plug in 2 for all those x values. That seems like a lot of work, right? That seems like a lot of work. So I don't really want to do that, but I know I can do synthetic division pretty fast. So what I have to do is take the 2, take my polynomial, divide it, and the remainder is going to be f of 2. So we call this the remainder theorem. Basically, you can use synthetic division to evaluate a function. So let's do this. So we peel off those coefficients. So we have 1, 6, negative 12, minus 30, plus 35. Perfect. Now we know this turns into a game. So we bring down the 1. 1 times 2 gives me 2. We add. 6 plus 2 gives me 8. 2 times 8 is 16. 16 minus 12 gives me 4. 4 times 8 is 8. 4 times 2 is 8. 8 plus negative 30 gives me 22. 22 times negative 22. Negative 22 times 2 gives me negative 44. And negative 44 plus 5 will give me 11. Negative 11. So that's going to be my function value. F of 2 gives me negative 11. Okay. So... Oops, negative 9. Negative 9. Okay, so cool. So we have this value, and we could test it. Do we get the same value? That's 2 to the 4th plus 6 times 2 to the 3rd minus 12 times 2 squared minus 30 times 2 plus 35. Now, this is going to take a little bit, right, to evaluate. So we'll get 2 times 2. 8 times 2 is 16. So we have 16 plus 48 minus 48. So that's cancels. Minus 60 plus 35. So that's going to give me 16 plus, or minus 60 plus 35. So that gives me negative 60 plus, that's 1, 3, 4, 51, which gives me negative 9. Okay, so yeah, so that's how we can quickly get, especially if you're not allowed to have a calculator to do large computations like that, or if you want to use the remainder theorem also. Okay, so another thing, so let's try this one. So let's try f of 7. So we get -7 in the corner, and we have that same spread. So 1, 6, -12, minus 30, plus 35. Draw our line, bring down the 1. So we have 1 times -7. That gives me -7. -7 plus 6 gives me -1. -1 times 7, -7 gives me a +7. 7 plus -12 gives me -5. -5 times -7 gives me +35. +35 plus -30 gives me 5. 5 times -7 gives me -35. And -35 plus 35 gives me 0. So what we can conclude from this is that the remainder 0, -7 goes into the polynomial evenly. So x plus 7 is a factor of this polynomial, right? The remainder, or we can say remainder, is 0. So f of -7 equals 0. And we know that when you plug in something into the function equals 0, isn't that the intercepts? Yeah, that is. So to test if a function has a root c, plug it into the function. If the remainder is 0, then c is a root. And so back to this example, we plugged in -7. C equals -7. We got the remainder 0. Therefore, -7 is a root. All right, so let's actually do this with a different example. Okay, so to test if a function has root c, plug it into the function using the remainder theorem. If the remainder is 0, then c is a root. So we need to we ask ourselves, is x minus 3 a factor of this function? So what we need to do is, the first thing is set up our synthetic division, divide this guy into this guy, see if our remainder is 0, and then go from there. So let's do this. All right, so the first thing that we want to do is set up our synthetic. Remember, we take the opposite sign of this inside. Since it's -3, we take +3. So we have 3. Now we have, let's set up our coefficients. So we have 1. We have -1, -11. We have 11. And we have 12. Okay, so let's bring down the 1. 1 times 3 gives me 3. 3 minus 1 gives me 2. 2 times 3 gives me 6. 6 minus 11 gives me -5. -5 times 3 gives me -15. -15 plus 11 gives me a -4. -4 times 3 gives me -12. And -12 plus 12 gives me 0. So since I have my polynomial was evenly divided by 3, we know that it is a factor. So remember, this started off as degree 4. We subtract 1, so we get degree 3. So now I want to replace. So I get x to the third plus 2x squared minus 5x minus 4. This all times x minus 3 times this. Okay, so that's just factoring out one of our factors. But if you remember from the last section, in order to graph a polynomial, we kind of have to factor the whole thing and find the roots. So we're not quite there yet to being able to graph like all kinds of functions or all kinds of polynomials that have additional terms. But as you can see, how we're going in the direction of being able to factor these huge polynomials. And so this synthetic division is very important that you become really good at it and really quick at it as well. Because like I said, we're going to be doing it a lot more, and hopefully it becomes kind of second nature to you. And the hardest thing is just making sure that your signs are correct with synthetic. And so that's going to be section 2.3, which is talking about all kinds of division.